Hey everyone, Patrick CK here with episode 10 of 3D printing with a Monoprice printer. I like to think this episode will be part creative experiment, part tutorial. I'm going to go over how I went from conception to creation of this. It's basically 4 concentric cubes inset into each other to create this cool geometric object. A little cubeception. I learned a lot in trying to model this thing to make it possible to 3D print. So I hope you appreciate the journey and learn something to help you in your 3D printing projects. We're going to be using Blender for the design portion. If you haven't started playing around with Blender, I would highly recommend it, especially if you plan on doing anything related to CAD or 3D printing in the future. A link to my series for Blender beginners will be in a card. Let's jump right into it. The individual cubes themselves are actually straightforward to model, and their design directly contributes to making them easy to 3D print. In Blender, we actually get to use the starter cube for once, add a sphere, scale it so it protrudes from the cube but doesn't engulf it, add a Boolean modifier to the cube. With the difference option, select the sphere as the object target. This modifier cuts the shape of the sphere out of the cube. Next, apply the modifier and delete the original sphere. Now we have a cube with a sphere cut out of it. The benefit of this design, besides just looking cool, is that it can be printed without any additional program supports. In case you're not familiar with supports in 3D printing, they are used when a design has an overhang that is not supported from below. Program supports are automatically added in slicing programs like Cura with this option and are identifiable by this turquoise color. You can tell where the program will add supports by looking for the red shaded areas on the underside of your design. Cura believes these areas cannot be printed without supports. Supports are meant to be printed in such a way that they use the least amount of material to support the model, and is only superficially attached so that it can be easily removed after the print is done. While these supports are very helpful in printing interesting shapes, it can create some issues. While they're designed to be removed easily, they can still leave a lot of leftovers. With intricate models, these remnants can be detrimental to remove, and if you're not careful, you can break the finished print. They can also be incredibly difficult to remove from a model with open interior spaces, kind of like our design. So the goal is to set up this model in such a way that program supports would not be required. The beautiful thing about the way this is modeled is that the spherical space inside the cubes are essentially arches. The beautiful thing about arches and 3D printing, just like in civil engineering, is that you can span considerable distances during the build process without additional support. This can be done because each layer of an arch prints just a fraction of a millimeter further in from the previous layer, so that it's still held up from below and can creep inward with each layer until the arch is connected. This accounts for printing the cube itself. Now, how do we inset the other cubes so that they all can be printed at the same time? Let's step through how I set up the 3 interior cubes and finish up this design. I wanted each of the interior cubes to be small enough to move around freely, but large enough so that it doesn't fall out of the parent cube. To accomplish this, for the first interior cube, I simply copied and pasted the original one, then scaled it down, again just enough to allow it to move freely and stay inside the parent cube. Simply leaving it to sit on the inside of the parent cube will not work. So what can we do here? With this cube, I found a pretty simple solution, which just involves rotating it 45 degrees on the y-axis, thus printing it on its edge directly on the print bed. Since none of the faces hang more than 50 degrees, and with the inherent benefit of the design that we already discussed, there is no need for additional supports. There was one caveat. I did end up beveling the 4 corresponding edges so that there was a flat surface to print the cube on. I went ahead and beveled all of the cubes to keep the design consistent. Figuring out how to orient that cube was fairly straightforward, but the next one was going to be a little more of a challenge. The third cube was again another scaled down copy, free to move but firmly inside the second cube. This cube is basically floating in midair. No part of it could touch the bed of the printer. So how can we print this cube where it is? I tackled with this problem for some time when I realized there was just enough room to create my own custom supports underneath to facilitate the printing of this cube. The challenge is how to add those custom supports so that it's enough to hold up the printing process and light enough to be removed easily after the print is done. The trick is to support the corners, since these are the points that the print head will travel to and from. From here, we can take advantage of a 3D printing characteristic called bridging. Basically, this is the ability to connect 2 points without supports in the middle. This can be done because as the printer extrudes filament in midair while moving to the next point, it basically pulls the filament along with it and thus can bridge a gap. Of course, this is highly dependent on the printer's capabilities. I ran a couple bridging tests to see how large a distance the V2 and MP10 can bridge before sagging too far. I found the V2 can bridge roughly 60 millimeters without a problem. The MP10 can do about the same. With that said, we just need to support the area from the outer corner to the edge of the interior at roughly 45 degrees to the center, which led me to this simple oblong oval shape that again will hold up the corners and will support the cube as it prints and allow for easy removal. Naturally, I did have to make sure this was the case with a test print of this cube alone. And here it is, our cube on custom supports. A very promising result and barely any sagging while bridging all 4 sides. With this print, we get a bonus test to see how easy breaking off these supports we added will be. From this test, it looks like it's going to be fairly easy. Lastly, the 4th cube was another interesting challenge, but all I had to do was look at the 2nd cube for inspiration. I could put this cube to print on its edge as well. This time though, it would need its own custom supports. Luckily, all I had to do was again look at what I did on the 3rd cube. Putting the 4th on its edge and adding 2 more supports not only allows the 4th cube to be printed, but also gives the 3rd cube additional support, which as we just demonstrated, isn't needed, but it won't hurt. I printed the 4th cube on its own to confirm the theory. Again, another promising result. Not very clean, but we can work on that. It's the physics that I was more concerned about. Here we have the final CAD model. We can see each cube individually, then all together, ready to be exported. After importing into Cura, I scaled the model to 50 millimeters across. I found this size to be optimal. It's large enough that all the cubes come out mostly clean, but small enough that bridging the 3rd cube, like we mentioned earlier, shouldn't be an issue. I set the infill to 100% to basically make it a solid object, which also adds rigidity to the smaller cubes. Of course, this does add to build time. I tried lower infill percentages, but the smaller cubes ended up more fragile than I'd like, so 100% was the way to go. There are plenty of other tweaks we can make with the printer settings like retraction speed, distance, wall thickness, etc. But it's best to leave everything as is and tweak the settings to suit your printer based on your results. Let's print it. And here we are. Removing the adhesion layer and breaking off the supports does take a little finesse. You definitely want to gently hold the 3rd cube while removing the supports. I found that if you bend them side to side just a little and then twist, they break off easily and cleanly. Needle nose pliers work best here, but scissors will do in a pinch. A cleaned up model is fun to mess with and makes for an interesting desk piece. I feel like this would make for a good stress test for any printer. Much like the Benchy we printed in previous episodes, it tests quite a few areas of the printer's capabilities. My results definitely could use some more work, I won't deny that. I'll explore some of those improvements in future videos. I'll provide the Blender and STL files on my site and on Thingiverse. Download them and give them a try for yourself. I'd be curious to see how these turn out for all of you. That's it for this episode. I hope you had fun with this one. If you did, please leave a like and share so others can find this content in the future. Until next time, this has been Patrick CK. Goodbye.